Summer Physics 3-4. We're on to our Day 12 lesson, and now we're going to deal with some of the calculations involved with waves. So what are the parts of a transverse wave? Transverse waves move in a repeating pattern. And what they do is they move in, you can think of it as an up and down like a roller coaster, and they go across a central line that you see, that horizontal line. And that's the word trans means across. So they go across that center line, up and down, up and down. Wavelength is the distance between the top of one wave, which is called the crest, and the top of the next wave. Amplitude is the distance from that midpoint of the wave, that center line, and the crest top of the wave. It could also be from that center line and the bottom of a wave, which is called a trough, but you'll never hear us use that term in class. So it's from the center line up to the crest. It's not from the trough, the very bottom, up to the very top. It's from the midline, and that's called the amplitude. So how is the speed of a transverse wave measured? When a transverse wave moves through space, the complete movement through a wave is called a cycle. The number of cycles that pass a point per second is called the frequency of the wave. 1 cycle per second is called a hertz, abbreviated Hz. So if you see crest 1, when the wave moves, as the wave is moving to the right, and you're standing at point A, you're going to see the wave as you're looking down on it. You're going to see it going down to the trough and back up to crest 2. That's 1 cycle. Now that kind of seems like the same thing as a wavelength, because a wavelength goes from crest 1 to crest 2. That would be a wavelength. But a wavelength is a distance. It's the straight line measure between crest 1 and crest 2. And it's measured in the units of distance, which is meters. A cycle is simply a number. It's how many times does the wave go down and come back up to the next crest, go down and come back up to the next crest. So it's simply a number. So that's the difference between a wavelength and a cycle. And if it does that, if it goes through a cycle in 1 second, that's called a hertz. And that's the frequency. So what you're seeing here is a before and after picture. You see 2 waves, but they're really the same wave. The one on the top is at 0 seconds. So you're standing at point A looking down on that wave. Then you start your stopwatch, and 1 second later crest 2 has moved over so that it's directly below you, and that's the bottom image. So again, it's like a before and after. The top one is at 0 seconds, the bottom one is 1 second later. So at 0 seconds, crest 1 is at point A. That's where you are. At 1 second, crest 2 has moved over to point A. So that's 1 cycle in 1 second. So that's a frequency of 1 hertz. At 0 seconds, crest 0 is at point A. So you're standing at point A looking down on crest 0. Then 1 second later, crest 4 has moved over to point A. It's directly below you. This is a frequency of 4 hertz. It's 4 cycles, 0 to 1, 1 to 2, 2 to 3, 3 to 4. That's 4 cycles in 1 second. That's 4 cycles per second. Don't make the mistake of counting the crests. You'll see that there's 5 crests. 0, 1, 2, 3, 4. That's 5 crests. It's not how many crests, it's how many cycles. How many times does it move between one crest and the next crest over? The period of a wave is the amount of time it takes 1 cycle to pass point A. So in the same wave that we looked at in the previous slide, if 4 cycles or wavelengths pass point A in 1 second, then that means it takes 1/4 of a second for 1 cycle to pass. So think about that. 4 cycles passed in 1 second. So from 0 to 1, it took 1/4 of a second. From 1 to 2, it took 1/4 of a second. That's up to 1/2 a second. From 2 to 3, that's 1/4 of a second. That's 3/4 of a second. And from 3 to 4, that's 1/4 of a second. That's a full second. So 4 cycles in 1 second, or one cycle every 1/4 of a second. So mathematically, the period is the reciprocal of the frequency. Period equals 1 over frequency. So at 0 seconds, crest 0 is at point A. That's where you're standing. At 1 second, crest 2 is now at point A. How many cycles have passed point A? Well, 0 to 1 and 1 to 2, that's 2 cycles. What is the frequency of the wave? Well, the 2 cycles passed and it went from 0 to 1 second. It says on the diagram down there. So that's 2 divided by 1 is the frequency is cycles per second. That's 2 hertz. What is the period of the wave? So the period is the reciprocal of the frequency, 1 over the frequency. So that's 1 over 2 or 1/2 second. Another example, at 0 seconds, crest 0 is at point A. At 2 seconds, crest 4 is at point A. So how many cycles have passed point A? Well, you see it went from crest 0 to crest 4. That's 4 cycles. What is the frequency of the wave? So now it's 4 cycles, but it took 2 seconds. So frequency is cycles per second. That would be 4 cycles over 2 seconds. So that equals 2 cycles per second or 2 hertz. And again, what is the period of the wave? It's the reciprocal of 2. It's the reciprocal of the frequency. So that would be 1/2 second. What is wave speed? Wave speed equals wavelength times frequency. Or V for velocity equals lambda. That funny looking upside down Y is the Greek letter lambda times F for frequency. So if you count the number of cycles, think of it as wavelengths that pass point A in 1 second, and then multiply by the length of each wave, you will get the speed or velocity of the wave that has passed point A in 1 second. And this is the wave speed. So there's the formula again. So a wave with a wavelength of 2 millimeters, so that's a unit of distance, that's a wavelength, has a frequency of 5 hertz, that's how many cycles, how many times it goes down and back up again. What is the wave speed? So very simple, velocity, wave speed, equals lambda, wavelength, 2 millimeters, times frequency, 5 hertz, there it is. There's the formula, you plug in the numbers and you get 10 millimeters per second. The velocity of 10 millimeters per second. So here's a summary of the abbreviations and units of measure for waves. Frequency is lowercase f, and the unit of measure is hertz. Period is capital T. That actually wasn't introduced earlier, but there it is. It stands for time, and it's measured in seconds, period. Wavelength is lambda, the Greek letter lambda. It's measured in some unit of meters, could be millimeters, centimeters, nanometers, something like that. And wave speed, which is V for velocity, is measured in meters per second. Alright, so that takes care of this. That's really all the math there is to waves, nothing any more complicated than any of that. I'll just give you a few problems to practice that.